Hi everybody. I had a few questions from the multiple derivatives homework assignment and one from the chapter review, so I'm going to go over those right now. The first one is number 70. You can see the function f of x and it asks us to find the second derivative, f double prime. So we're taking the derivative twice, and if we do it the way it's written using quotient rule, it would actually be a very hard question. So I think this is one of those I'm going to do some rewriting at the beginning. So I'm going to do this since we only have one term in the denominator. Remember, that's when you're allowed to do this. I'm basically going to take each term from the numerator and put it over that denominator separately. And then I'm going to simplify each one. So x squared over x just equals x. 2x over x just equals 2. And then 1 over x, we're going to write as x to the negative 1 power, so we can use power rule. So now when I go to take the actual derivative, f prime, it's much easier. It's a quick, easy question, whereas the original problem would have been quotient rule, would have been a mess. So for this one, the derivative of x is 1. The derivative of 2 is 0. I'm just going to leave that off. And for the last one, the last term, I'm going to do power rule. So I'm going to multiply by negative 1, which is going to turn that into a plus. And then I'm going to lower the exponent by 1. Negative 1 minus 1 is negative 2. Now, to find the second derivative, which is actually what we're trying to do here, find f double prime, I'm just going to do that again. I'm going to take the derivative of the blue one. Now, the derivative of 1 is 0, so that's going to disappear. So all I have to do is take the derivative of that second term, and it's going to be power rule. So I multiply by negative 2. I lower the exponent by 1, that would be negative 3. And actually, that's perfectly fine for an answer. Or if you needed to or wanted to, you could rewrite it as negative 2 over x cubed. Either one of those is fine for that. But that first step up there in red, this work is important because it makes the blue and purple work so easy. Without that work at the beginning, you would have had to do quotient rule twice and it would have turned into a giant mess. All right, the second homework question was number 72. I'm going to rewrite this one. Before I even look at what I'm asked to do, we were given f double prime. I'm going to do the same thing with negative exponents I did in the last example. I'm going to write that 2 over x as 2x to the negative 1. Now, I'm going to look carefully at what I'm given, which is f double prime, and what I'm asked to find, which is f triple prime. So all this really is a derivative question. All you guys are being asked to do here is take the derivative once. This is more of a notation check than anything else. Make sure you understand what the 2 and 3 different apostrophes mean. But I could have given you this question back in the first section on power rule and just said, here's f of x, find the derivative, and it would be the exact same question. But when I take the derivative of f double prime, it gives me f triple prime, which is what I'm trying to find. And now we get the easy power rule work again. The derivative of 2 is 0. I'm just going to have that disappear. So I do power rule here. Negative 1 times negative 2 gives me positive 2. Lower the exponent by 1, you get negative 2. And then same situation as the last problem. That's fine for an answer. Or if you wanted, you could rewrite it as 2 over x squared. Either of those is good for an answer. But the key to this one was looking at the two things I circled in blue and realizing I just asked you to find the derivative. Just once, that's it. Not, this was not even a multiple derivative question. It involved multiple derivatives and you had to understand the notation, but you were really just taking the derivative once. Okay, the third question was number 81. This is the one I accidentally assigned one assignment early and I said I was going to push back because I wanted you guys to know the notation. And now we can talk about it. So basically in the book you had these 3 graphs and it says one of these is f of x, one of them is f prime, and one of them is f double prime, the second derivative. And that's the reason we had to wait. You didn't know what f double prime was yet, but you do now. So basically we're looking at 3 graphs, the function itself, the derivative, and the second derivative. Now what you want to realize is every time I take the derivative using the power rule, I drop the power by 1. Like if I start with an x cubed and I take the derivative of it, what I end up with is, by power rule, I end up with 3x squared. And if I take the derivative of that, I end up with 6x to the first power. So basically, every time you're taking the derivative, the power drops by 1. Now, if you look at these three functions, the red one is linear. That's like an x to the first power. The purple one is a quadratic. That's basically some sort of x squared function. And the blue one looks like x cubed. It's a cubic function. So based on that, the cubic function, the blue one, has to be your original function, f of x, the highest power of x. And then when I take the derivative, I get x squared, because I'm lowering the power by 1. And when I take the derivative of that, which gives me f double prime, I get the linear function. I get x to the first power. So what you're realizing here visually is that every time I take a derivative, I lower the power by 1. If my original function is x cubed, and it may not be exactly x cubed, but it's some sort of third degree polynomial, then when I take its derivative, it's going to give me some sort of x to the second polynomial. And when I take the derivative of that, it's going to give me some sort of linear function, x to the first power. So that's the key to that one. That was a visual representation of understanding that every time you take the derivative using power rule, you drop your power of x by 1. The last question that I was asked today was from the chapter review section. It was number 1. And it gave us a function g of x, and it asked us to find the equation of the tangent line at this point here, negative 1/5/6. So all I really need is the slope. In fact, basically, if you're thinking about your answer right now, you can fill in almost everything right now, because when we're ready to answer this question, I'm going to use y minus y1 equals m times x minus x1. That's called point slope form. And we already have the point. Here's our x1, y1. So I'm going to have y minus 5/6 equals, now m is the only thing I don't know yet. But I also have x, now that would be a plus 1 since the point was minus 1. You have x minus a negative 1, which becomes x plus 1. So all I need to do is figure out what goes here, and I'll have my answer. Now to do that, I'm going to use derivatives. So let's go back to the problem over here, and let's find g prime of x. So for my first term, actually, you know what? Let me rewrite this real quick, because I don't like that x over 6. I want you guys to realize that when you have x over 6, that's the same as having 1/6 x. So that's still a linear function, and you're still going to use power rule. Now, let's find g prime. So now I'm going to do power rule. On the first one, I multiply by 2, which would give me 4/3 x to the first power. Lower the power by 1, you get 1. Now, see right here, when you're looking at this derivative, that may be confusing. You know, the derivative of x over 6, what is that? Do I have to do quotient rule? What? Now, all of a sudden, when you look here, you realize it's just minus 1/6, because that's an x to the first power, and the derivative is just its coefficient. So g prime is 4/3 x minus 1/6, and to find the slope, m, we are going to plug in x, which if you look back at the point up there was negative 1, into that function. So remember, this is where we find x up here. X is the x coordinate from the point. So if I plug negative 1 into that function, I have 4/3 times negative 1 minus 1/6. That would be negative 4/3 minus 1/6. Common denominator would be 6, so I'll have to multiply by 2 on this first one. Negative 6 over 6, or negative 8 over 6, sorry, minus 1 over 6 equals negative 9 over 6, which reduces by 3. So my slope is negative 3 over 2. And remember, that's all that work over there was just to find this one last missing piece. The slope of the tangent is negative 3 over 2. And this is my final answer there. And that's a good review of how to find the equation of a tangent line. We need the slope, which is most of the work. Most of the work is taking the derivative, plugging in x, finding the slope. We also need a point, which can be given like it was here. Or remember, the other thing is, sometimes on this question, instead of giving you the point, I say, when x equals -1. And if you take that -1 and plug it into the original function, that's where the 5/6 comes from. So it's going to be one of those two things on this question. I'm either going to give you a point or an x value, and you need the point one way or the other. All right, so those were all the questions I had. If you guys have more over the next day or two before the test, definitely email me. I can make another video very easily and send it out, but hopefully this helped you guys.